So in this video we're going to look at multiplying two matrices together. And we've seen how to add two matrices, and we noted that you can only add them if they have the same dimensions. We've also looked at scalar multiplication, where you scale the entire matrix by a number on the outside of that matrix, and that distributes to every number in the inside. But matrix multiplication, meaning multiplying two matrices together, actually has its own set of rules, and this example is meant to illustrate why those rules make sense. So, the situation is that you own a candy store and you're selling Easter baskets. And so you have three different baskets you can sell. Basket 1, basket 2, and basket 3 here. So basket 1 consists of 5 Milky Ways, 8 Snickers, 7 Cadbury Cream Eggs. Basket 2, 6 Milky Ways, 6 Snickers, 7 Cadbury Cream Eggs, etc. Now, you have to buy the Milky Ways, the Snickers, and the Cadbury Cream Eggs from a supplier. And so over here you have the supplier matrix. And so Hebert sells Milky Ways for $1.50, Snickers for 95 cents, and Cadbury Cream Eggs for $1.30. Lintz Milky Ways for $1.35, Snickers for $1, and Cadbury Cream Eggs for $1.25. And so your goal here, and what's written in yellow, is we need to construct a matrix that shows the cost of making each basket supplied by Hebert's and Lintz. So, before we do any matrix multiplication formally, let's just do this the way we would do it as though we knew nothing about matrices. Let's figure out the cost to make basket 1 if we're going to go to Hebert's. So, how would we compute that? Well, basket 1 has 5 Milky Ways, and if I'm buying them from Hebert's, they are $1.50 each, so it would be 5 times $1.50. And then I'd add that to my 8 Snickers, which each cost 95 cents. And then I'd add that to the 7 Cadbury Cream Eggs, which cost $1.30 each. Okay, now if you add those up and put them in the calculator, which I've done ahead of time, you get $24.20. Basket 2 would be, well, 6 Milky Ways at $1.50 each. Six Snickers at 95 cents each. And 7 Cadbury Cream Eggs at $1.30 each, for a total cost to make basket 2 from Hebert's being $23.80. And finally, basket 3, I'll do this one a little more quickly. 4 Milky Ways, $1.50 each. 3 Snickers at 95 cents each. And 3 Cadbury Cream Eggs at $1.30 each, giving you a total of $12.75. So that's for that's making each basket if we're going to Hebert's. What would we do if we wanted to figure out the cost of going to Lintz? Well, basket 1 from Lintz would be basket 1 has 5 Milky Ways, $1.35 at Lintz, so that would be 5 times $1.35. Now, as I'm doing this, pay attention to how the numbers are interacting in the matrix. So 8 Snickers. At Lintz, it's $1 for each Snicker, plus 7 Cadbury Cream Eggs at $1.25 each. For a total of $23.50. So what I want you to notice is, as I'm going across the row on the left-hand column, I'm going down the column in the right matrix, and I'm multiplying and adding, right? So I'm multiplying the entry in row 1 of the matrix on the left with the entry in column 1 on the matrix on the right, and then I'm moving across on the left matrix and down on the right one. So quickly, I'm just going to do the next two. This would be 6 times 135 plus 6 times $1 plus 7 times 125, which gives you a total of $22.85. And finally, basket 3 from Lentz would be 4 times 135 plus 3 times $1 plus 3 times $1.25, giving you a total of $12.15. Now, this is not, what I've written below the yellow is not the most organized way. It shows the computations, but it's not the most organized way to display the information. The best way, I think, to display the information would be to make a new matrix where we have the cost of basket 1, basket 2, and basket 3, buying them from Hebert's and then buying them from Lentz. So we see that buying them from Hebert's, right, basket 1 from Hebert's would be this top left entry. That cost a total of $24.20. Basket 2 costs $23.80, and basket 3 cost $12.75. And basket 1 from Lentz costs $23.50, $22.85, and basket 3 costs $12.15. And so what you'll notice is, or what you may not realize, is what we just performed was matrix multiplication. We multiplied this left-hand matrix by this right-hand matrix, and it produced a new matrix. That is matrix multiplication, and the rules for matrix multiplication are here. And in a further video, I'm going to be more explicit about how the rules work. But for now, I want to point out two things. One is, it is very important that the dimensions of your matrix fit in a particular way. So what do I mean by that? Well, let's describe the dimensions of the left-hand matrix. This has 3 columns and 3 rows and 3 columns, so it's a 3 by 3. And the right-hand matrix has 3 rows and 2 columns, so it's a 3 by 2. Now, what allowed this multiplication to happen, as we did it here below, was that we were moving across these rows here on the left as we were moving down the columns on the right, right? As you're moving across the row, you'll notice that you have 3 entries. That's because there are 3 columns. The reason we can move down on the right-hand matrix 3 entries is because there are 3 rows in that matrix. So it is very important that when you multiply matrices, that the number of columns in the first matrix is the same as the number of rows in the second. That's one thing to notice. The second thing to notice is that our new matrix has dimensions 3 rows, 2 columns. And that is precisely how many rows we have in the first matrix and how many columns we have in the second. So that is not an accident. So this is just a kind of an informal example of how matrix multiplication, or why matrix multiplication has the rules it does. I haven't really specifically set the rules, but I have at least showed you what has to happen to multiply 2 matrices. Now, this all can be done also on your calculator. If you go, I've already entered these into the calculator, these 2 matrices, so I'll just show you that. If you look at matrix A, I put in the info for my baskets, and if you go to matrix B, I put in the costs. And so if you go to the quit screen and multiply matrix A times matrix B, you'll see here precisely what we got on the last page. Right? Now what happens if you multiply matrix B times matrix A? So what we see here up on the screen now is matrix A, so I'll call this matrix A, and this is matrix B, and when we multiplied them, we got A times B, and we got an answer, right? We got the answer on the last page. If you do B times A, the reason it's not going to work is because B times A is taking a 3 by 2 matrix and multiplying it by a 3 by 3, and you'll see that these inner dimensions don't match. The number of columns in row B do not match up with the number of rows in row A, and your calculator, you'll see, will not be able to produce that multiplication, as I'll indicate here. It says error dimensions mismatch. So matrix multiplication has to occur in a certain way. Your dimensions have to match in that certain way. Otherwise, you can't do the multiplication.